Okay, folks, are you as pumped as I am? We are about to begin the construction of our first proof. This is the core of what this course is about. We're going to use the process of proof construction in order to engage in the logical analysis of various forms or underlying logical structures contained in various arguments. We start off with another one of these catch-2 situations. In order to understand what we're doing when we're constructing proofs, you have to have a bit of theoretical background. On the other hand, in order to fully appreciate the significance of this theoretical background, you have to have done a few proofs. So here's what I'm going to do. I will fill in this theoretical background, and you probably won't understand it fully the first time we go through it, but the idea is you'll get a general sense of what we're up to. Then we will go on and construct a number of proofs. Then we'll go back and read this theoretical background a second time. That's what I found to be the most effective way of understanding what proof construction is all about. I'm going to read straight from page 9 and 10 of the sum notes and exercise notes. So remember, you don't need to write this down. You've got these notes for you. We start off on page 9. The crucial feature of all 8 basic rules of inference is that these rules are truth-preserving. That is, they outline simple, basic patterns of inference where the truth of the 1, 2, or 3 sentences above the horizontal line requires the truth of the inferred sentence below the horizontal line. In other words, if all of the sentences above the line are true, then A, it is necessary for the sentence below the line to be true as well, or another way of putting it, it's impossible for the sentence below the line to be false. Thus, all 8 of the truth-preserving basic rules of inference describe valid inferences, or we might think of them as very simple, valid arguments. Simple arguments that we can tell just by thinking about their implications that they're valid. They're simple enough to enable us to do that. We can also think of individual applications of any of these 8 basic rules of inference as single links in a longer chain of inference, or as single steps or stages in a larger series of inferences. And this is what we're going to do in the process of proof construction. Before we proceed to our concrete example, though, I'll read out the 4-stage rationale underlying proof construction, and then just a little bit more review material about the 8 basic rules themselves. Stage 1. You start off, when you're constructing a proof, with one or more sentences, one or more bits of information that you assume are all true. We've considered these before. These are your premises or premise set, the information you start out with. On the basis of this information, we're going to use some yet unknown number of individual applications of one of the 8 rules of inference. You'll see what I mean in just a few minutes. The information you have to work with determines which, if any, of the 8 rules you are entitled to use. You can't just decide to employ any of the various basic rules of inference. You have to have all of the sentences above the line before you can use any of the 8 rules of inference to derive the sentence below the line. Again, you'll see in very concrete fashion exactly what I intend by those statements in just a few minutes. Each proper use of a rule increases the number of sentences you have to work with. You'll see what I mean by this as well. Your goal, you should be able to understand this right now. Your goal when you're constructing a proof is to derive the conclusion that you have been asked to derive by constructing a series of individual rule applications that starts with your initial premise set and ends with your conclusion. So it's always going to be this way. You aren't just going to be given information and asked to start deriving things. You're always going to be given some specific information, a concrete set of premises, along with a particular conclusion. And you're going to be asked to construct a proof that if that set of premises are all true, then the conclusion must be true as well. And the idea is, if you only use individual applications of the 8 basic rules to construct the series of inferences that constitutes a proof, then each link in the chain of inferences you're constructing is going to be truth-preserving or valid. Thus, the entire series of links from the initial premises to the conclusion is also valid. One last review. Key point. Each new line in a proof is an entirely separate logical operation. For each new line in the proof, you start again by scanning the continually enlarging set of available sentences looking for a rule employment opportunity. You have found a rule employment opportunity whenever you have isolated the one line of information in the case of the rules simplification and addition, the 2 lines of information in the case of the rules modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism, and conjunction, or the 3 lines of information in the rule constructive dilemma that are required to employ that particular basic rule or valid argument forms of inference, as they're sometimes called. All right, so I hope you've got a basic sense of what we're up to. Don't worry if at a number of points you're not exactly clear about what I'm getting at in what I just read. We're going to do a few particular proofs, then we'll go back and review that information. And it'll make a fair bit more sense when we go through it the second time after having constructed a few proofs. We're going to begin with assignment 5. This is on page 11 of the Some Notes and Exercises. The exercise is exercise 4.2, and if you notice, the exercise tells us to use modus ponens, modus tollens, disjunctive syllogism, and hypothetical syllogism to prove that the following arguments are valid. So we've got a little bit of a simplified situation. There are 8 basic rules, but for our first exercise, we're just going to focus on 4 of them. First, we've got modus ponens. Then we've got modus tollens. Then we've got disjunctive syllogism. And finally, we've got hypothetical syllogism. So notice, with these four rules, there are always two lines of information above the horizontal line that are configured with each other in a very specific way. For modus ponens, we've got some conditional and its exact antecedent. With modus tollens, we've got some conditional and its exact consequent with a tilde in front of it. With hypothetical syllogism, we've got two conditionals where the consequent of one of them is identical to the antecedent of the other one. Finally, with disjunctive syllogism, we've got some disjunction and one of the disjuncts with a tilde in front of it. The idea is we have to have all two of the lines of information required in order to employ any of these four rules. That is to say, we have to have two specifically related sentences in order to have a rule employment opportunity. Those two specifically related sentences are what's necessary to have a legitimate rule employment opportunity. Over the next few weeks, as a result of doing a fair number of different proof constructions, you're going to become increasingly skilled at spotting rule employment opportunities. That is to say, subsets of your available information that entitle you to employ a rule and infer a new sentence. When we start off, it might be a little bit of a slow and mechanical process for some of you. It depends on how well you know these rules. But like so many things in this course, the more proof constructions you carry out, the easier, the more intuitive this process of proof construction will become. So what I've got up here is assignment 5, exercise 2.4, on page 11 of the notes and exercises, question 9. Since this is our first proof, I will begin by describing what a proof looks like and the different parts of it. Think of a proof as a series of 3 columns that are all side by side. The leftmost column we just call the line number column. So all that is a numbering of each of the individual premises on a separate line, and then once the premises have all been written out, there's going to be a number of additional lines that are going to be used for what are called lines of inference. At this very early point, we haven't really learned any methods yet. You're just learning this new process. So all we can really say is it's going to take some yet unknown number of lines of inference or individual inference steps to derive the assigned conclusion. Now, if you look at the question itself, it's got the number 1, then it's got this sentence, a conditional with a negated sentence as the antecedent, a disjunction as the consequent, then a negated sentence, then a simpler conditional, and then another negated sentence. Notice then there's a backslash and 3 dots. That's used by a number of logic books to separate the premises or the proving sentences that you're assuming to be true from the conclusion. It's useful to put the assigned conclusion up at the top in the middle. That tells us what we're aiming for. What we want to do is construct a sequence of strategic rule employment steps, the last of which is going to be the derivation of this sentence. Are you ready? Off we go. Here's our first line of inference. For that line of inference, we're going to focus on lines 1 and 4. So as far as line 5 is concerned, that's the first line of inference in our proof. All we care about are lines 1 and 4. We're completely ignoring lines 2 and 3. Lines 1 and 4 are true because they represent a rule employment opportunity. They satisfy the information conditions for correctly applying one of the 4 rules. That rule is modus ponens. What we have is a conditional in line 1, and we've got the exact antecedent of that conditional in line 4. If lines 1 and lines 4 are true, then the additional sentence that must be true is the consequent of that conditional, which in this case is the disjunction A or B. So if lines 1 and 4 are true, then by modus ponens, the disjunction A or B must be true. Now, where all of the symbolic stuff goes, it's what's called the main proof column. Finally, at the rightmost part of the proof itself is what's called the justification column. Every sentence has to be justified. As far as the 4 premises go, the justification for them is that they're premises. We are assuming for the sake of argument that they are true. We're temporarily assuming that all 4 premises are true in order to make a validity determination. If the argument turns out to be logically flawless, we may go back and have to go through the more laborious process of ascertaining whether or not each of these individual claims are true. But for now, we're assuming they are true. So all we can do is put premise in each of the 4, or for each of the premises, but starting in line 5, where we are inferring new lines of information, there's going to be two parts to the justification column. So I'll put two parts to the justification column for what are called inferred lines. So the first part is the line or lines referred to, that is to say, the subset of all four lines of available information from which you're basing your inference. And the second part of the justification is the rule applied to the line or lines referred to. So, in the case of line 5, we put 1 for modus ponens. Notice no comma, no divider between the lines cited, 1 and 4, and the rule employed, or the abbreviation for it, modus ponens. Now, we move on to the second line. So our first logical operation, our first inference in the proof is over. So now, instead of having 4 lines of information at our disposal, we have 5 lines of information at our disposal. So we start all over again. We scan the 5 lines of information looking for another rule employment opportunity. So we've already carried out the rule employment opportunity in lines 1 and 4. Now we carry out the rule employment opportunity made available to us with lines 2 and 5. Lines 2 and 5 are a disjunction and the negation of the right disjunct. If the disjunction A and B is true and the negation of B is true, what further sentence must be true according to the rule disjunctive syllogism? Answer, the other disjunct. So we put the other disjunct, A, in the main proof column. We put the lines we referred to, in this case 2 and 5, in the left-hand side of the justification column. Then we put the abbreviation for the rule employed, in this case disjunctive syllogism, in the right-hand side of the justification column. So there's always going to be 3 things to write down in each. There's always going to be 3 things to write down in each new line of a proof. First of all, there's going to be the newly inferred symbolic sentence. That's going to go in the main proof column. Then there's going to be the subset of available information that is focused on in that particular step in the proof. In line 6, that's going to be lines 2 and 5. Then there's going to be the abbreviation for the basic rule applied to those lines of information. So we've now completed the second line in our proof. Now we start all over again. Each new line of a proof, you start all over again. But notice, we started off with 4 lines of information. After 1 line of inference in the proof, we've now got 5 lines of information. After 2 lines of inference in the proof, we've now got 6 lines of information. We scan the available data, looking for a rural employment opportunity, and there it is, lines 3 and 6. We've got a conditional and its antecedent. So modus ponens entitles us to validly derive the consequent of that conditional, which is D. And at this very early stage, since that was our goal line, that's how we know it's time to end the proof. So this was a fairly short and straightforward proof. 3 lines of inference took us from our 4 premises to the conclusion. So what these 3 lines of inference demonstrate is that if these 4 lines are true, our 4 premises, it's impossible for the conclusion to be false. We don't want to do this every time we do a proof, but I'll just set out for you the justification of what we've done in sequential fashion. We've started off presupposing that lines 1, 2, 3, and 4 are all true. The task before us is to demonstrate that if lines 1, 2, 3, and 4 are true, it's impossible for our assigned conclusion D to be false. Just by looking at lines 1, 2, 3, and 4, you probably can't tell with certainty that if these lines are all true, if this information is all true, it's impossible for D to not also be true. Now we can construct a proof that that's so. If these 4 lines are true, D must also be true. Here's how the rationale works. If lines 1 to 4 are true, then lines 1 and 4 are true. If lines 1 and 4 are true, then if modus ponens is a valid form of inference, a valid way to reason, then line 5 must be true. Modus ponens is a valid way to reason, therefore line 5 must be true. Therefore, if lines 1 to 4 are true, lines 1 to 5 must be true. We can carry this on. If lines 1 to 5 are true, then lines 2 and 5, a subset of them, must be true. If lines 2 and 5 are true, and disjunctive syllogism is a valid form of inference, then line 6 must be true. Disjunctive syllogism is a valid way to reason, therefore line 6 must be true. Therefore, if lines 1 to 4 are true, line 6 must be true. That's what we've demonstrated in the proof. So do you see how important it is that each of these basic rules of inference be valid? So if there's any question about the validity of any of these basic rules of inference, we have to stop and ensure ourselves that all of these all of these inference patterns are unquestionably valid. That is to say, in any situation where the two lines of information above the horizontal line are true, it's impossible for the sentence below the horizontal line to be false. So that's our first proof. Here's the second argument we're going to consider. This is on assignment 5, page 11, question 10. Like question 9, we've got 4 premises. The 4 premises are a little different, and our conclusion this time is the sentence C. So, once again, you can ask yourself, can you see that if these 4 sentences are true, it's impossible for this conclusion C to be false? Now we can construct a proof of that. This will be useful, first of all, to ensure ourselves that if these 4 lines are true, C must also be true. But we can also explain it to anyone who doesn't think so, simply by walking them through the series of steps that are rule employments of, in this artificially simplified situation, one of these 4 rules to some subset of our available information. Once again, we need to be familiar with the rules in order to easily spot rule employment opportunities. Can you see a 2-line subset of this information that is either a disjunction, one of the disjuncts with a tilde in front of it, a conditional and its antecedent, a conditional and the negation of its consequent, or 2 conditionals where the antecedent of one is identical to the consequent of the other? We'll start off here. 2 and 4 satisfy the rule employment requirements for disjunctive syllogism. We've got tilde D or A in line 2. In line 4 we've got the negation of the right disjunct. That entitles us to validly infer the left disjunction, tilde D. So notice, always 3 things to write down for every new line of inference. The newly inferred symbolic sentence, the subset of available information that you focus on in order to infer that sentence, and the basic rule you apply to that subset of information. There is no official correct order for these 3 things. What you'll begin to find fairly quickly is all 3 of these things will strike you simultaneously. All 3 of them are different aspects of a single task where you isolate a particular subset of the information, and you isolate it because it satisfies the rule employment requirements for one of the rules, and that entitles you to validly derive the conclusion or inferred sentence or below the line sentence for the particular rule of inference you're employing. Now that we've carried out the first line of the proof, instead of having 4 lines of information at our disposal, we now have 5 lines of information. So we start all over again. This time we can focus on lines 3 and 5. That satisfies the modus ponens rule employment requirements, and it entitles us to validly infer the consequent of the conditional in 3, which happens to be a smaller conditional. So, having carried out that second step in the proof, that second line of inference, where we specified the newly inferred sentence, the subset of available information we focused on, and the rule we applied to that basic information, we now have not 4, not 5, but 6 lines of available information. Once again, we focus on the rule employment opportunities available. 1 and 6 satisfy, once again, the rule modus ponens. So there is no restriction that, let's say, since we already used modus ponens in line 6, that we can't use it again. Each new line of inference is an entirely new logical operation. Any of the available rules can be employed if you can specify a subset of your information that satisfies the rule employment requirements. So in 1 and 6, we've satisfied the rule employment requirements for modus ponens a second time, and this entitles us to infer the consequent of the conditional in line 1, which is C. So, once again, we've got an argument that started off with 4 premises. It took us 3 lines of inference to conclusively demonstrate that if the 4 premises are true, it's impossible for the conclusion to be false. Before we move on to another question, I just want to consider a different way of doing question 10 in assignment 5. So the way I just showed you is entirely correct, but, and this is a typical situation in logic, there can often be 2 or maybe 3 alternative entirely correct ways to construct a given proof. This certainly doesn't mean that anything goes. There's always going to be exponentially more ways to screw it up, but often there can be a very narrow range of alternative correct answers. Sometimes there's only one correct way to do it. Our first proof was like that, but often there can be 2 or 3 entirely correct alternative ways to do it. For this particular proof, instead of starting off by doing 2 for disjunctive syllogism, someone might notice that lines 1 and 3 satisfy the rule employment requirements for a rule we haven't used yet, namely hypothetical syllogism. The antecedent of line 1, which is a smaller conditional A horseshoe B, is identical to the consequent of line 2. And remember, they don't have to be in the exact order of the template. You just have to have all of the information. So lines 1 and 3 satisfy the hypothetical syllogism rule employment requirements. And from lines 1 and 3, by hypothetical syllogism, we can validly infer the new conditional D horseshoe C. Or sorry, tilde D horseshoe C. After having carried out that correct rule employment, noting the 1, 2, 3 things that need to be written down for each new line of inference, we now return to our data set. Instead of having 4 lines of available information, we now have 5 lines of available information. So we have to look for a rule employment opportunity. Here, this is the one we started off the proof with, 2, 4 disjunctive syllogism. That'll give us tilde D, as we saw, the left disjunct. Then we can finish off the proof by focusing in on this subset of our now 6 lines of available information, 5 and 6. We've got a conditional and its antecedent, which satisfy the modus ponens conditions and entitle us to validly infer the assigned conclusion C. So this is also an entirely correct answer. So as far as the test goes, and I'll just tell you now, the second test is only going to consist of proof construction questions. They're going to be of various degrees of difficulty. So either the first way or the second way that I've just shown you would be entirely correct proof constructions that would receive full marks. All right, we can now consider another question. Now we have question 11. Once again, we've got 4 premises. This is just a coincidence. An argument could have 1 or 2 premises, could have 5 or 6. Turns out the first 3 arguments we're considering all have 4 premises. That being said, you might want to pause the video, see how far you can get at constructing a proof that if these 3 sentences are true, or sorry, these 4 sentences are true, tilde B must be true as well. Hopefully you're getting into the swing of it. So we look at our 4 lines of information. We're looking for conditional antecedent, conditional negation of consequent, 2 conditionals where the antecedent of one is identical to the consequent of the other, or disjunction and negation of one of the disjuncts. One, 3. Oh, not disjunctive syllogism. an instance of a phenomenon that, as far as I know, it's impossible to get rid of. And this is that even though you know exactly what you're doing, you might, as I did here, I wrote down disjunctive syllogism, when obviously with lines 1 and 3, the rule that we're entitled to employ is hypothetical syllogism. The consequent of line 3 identical with the antecedent of line 1. Why did I write down disjunctive syllogism then? The fascinating answer is not that I'm too dumb, but that I'm too smart. At the same time I was thinking about this, I was also thinking about the fact that 2 and 4 are an alternative possibility, an alternative satisfaction of the rule employment requirements. Human beings have this marvelous capacity to multitask. So in a lot of ways, that's a very advantageous feature, but one drawback of this multitasking feature is that sometimes we don't pay sufficient attention to the task at hand. This is what was happening here. I wasn't focused enough on the fact that I'm setting out the line of inference involving lines 1 and 3. That being said, 1 and 3, we've got 2 conditionals that are configured in the appropriate way. So that entitles us to validly infer a new conditional with the unique antecedent and the unique consequent, which is itself a smaller conditional. Having set that out then, we can now move on to for disjunctive syllogism. There we have a disjunction and the negation of the right disjunct. This gives us the left disjunct. So, some of you, it might have occurred to you if you did the proof yourself earlier by pausing the video to do the disjunctive syllogism first and then the hypothetical syllogism. Either way is perfectly legitimate. Now that those are done, once again, we've got 5 and 6, which satisfy the modus ponens requirements. Got a conditional in 5 and the exact antecedent in 6. That entitles us to validly infer the consequent of line 5, which happens to be a smaller conditional. Finally, here's what's a little different. Instead of having 3 lines of inference, as we did in the previous proofs, we can now finish off the proof after having carried out 3 separate inferences in line 5, line 6, and line 7. We now have 7 lines of available data, and the ones we want to focus on to finish things off are lines 2 and 7. The first time we get to employ modus tollens. We've got a conditional in 7, and the consequent with a tilde in front of it in line 2. That entitles us to validly derive the antecedent of line 7 with a tilde in front of it. So that gives us the assigned line. So this particular one took us 4 lines of inference. I'll leave the remainder of the exercise for you to do. Before we move on, however, I'll just go back to pages 9 and 10. In particular, let's look at the 4-step rationale underlying proof construction now that we've had an opportunity to carry out a few proof constructions. So, you start off with one or more sentences that you assume are all true. These are our premises. They're going to be different for each question. In the justification column, we just indicate that they're premises. We're assuming that they're true. That's the justification for asserting them. On the basis of what's often called our initial premise set, we're going to use some yet unknown number of individual applications of one of the 8 rules of inference. So in this case we did 4 of them. And as we progress, we'll become increasingly skilled at estimating or getting a sense of how many individual steps are necessary in a given proof. But at this very early stage, all we're doing is getting used to this 3-component procedure where for each new line we look to write down the newly inferred symbolic sentence, which comes from applying one of the basic rules to some subset of our available information. And remember, the information you have to work with, so when we first start off, that's our initial premise set, that determines which, if any, of the 8 rules you're entitled to use. Or, in this simplified case of exercise 2.4, the 4 2-line rules we're entitled to use. In this particular argument, recall, lines 1 and 3 satisfy the rule employment requirements for hypothetical syllogism. Lines 2 and 4 satisfy the rule employment requirements for disjunctive syllogism. That's a little bit of an unusual situation where we've got not 1 but 2 rules we're entitled to employ. In any case, here's the important thing. You have to have all of the sentences above the line, all 2 of them, not in the exact order, you just have to have both of them in any order before you can use any of those 4 rules to derive a new line of information. Stage 3. Each proper use of a rule increases the number of sentences you have to work with. So we've seen this. We started off with 4. In line 5 we did a hypothetical syllogism. Now we've got 5 lines of information. Line 6 we did a disjunctive syllogism. Now we've got 6 lines of information. In line 7 we did a modus ponens. Now we've got 7 lines of information, and so on. So what we're doing, or a way of looking at what we're doing in proof construction, is we are gradually enlarging our data set. And the last line of this gradual enlargement process is going to be the derivation of the assigned conclusion from some subset of our gradually enlarged data set. Just to remind ourselves, your goal, this is stage 4, to derive the conclusion you are asked to derive by constructing a series of individual rule applications. So in the first 2 proofs we considered, the series of individual rule applications consisted of 3 applications. In this particular proof, it's a series of 4 individual rule applications. Starts with our initial premise set, ends with our conclusion. The key idea, the key rationale underlying this process If you only use one of the 8 basic rules to construct this series, then each link in this chain of inferences is going to be truth-preserving or valid. Thus, the entire series of steps from the initial premises to the conclusion is also valid. Key point: each new line in the proof is an entirely separate logical operation. For each new line in the proof, you start all over again. What you're doing is scanning the continually enlarging set of available sentences, looking for a rule employment opportunity. That is to say, looking for a subset of information in your available data set that satisfies the rule employment requirements for one of the rules. The rule employment requirements are just the sentences above the horizontal line in the template for that rule in any order. So here's another way of looking at it. You have found a rule employment opportunity, or an instance that satisfies the rule employment requirements whenever you have isolated the one line of information necessary to employ simplification or addition. Those are examples of what we can call one-line rules, or the 2 lines of information for modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism. These are the 4 we considered in this first exercise. We can also add conjunction, or the 3 lines of information required for the elusive constructive dilemma. So, acquaint yourself with this new activity for many of you, constructing proofs which are series of individual rule employments applied to subsets of your increasingly larger set of available data that end when you've derived by an individual application of one of the rules your assigned conclusion. Having now completed a sufficient number of the questions in assignment 5, we're ready to move on to assignment 6. Before we do that though, I want to pause and repeat something I've said before because it's worth re-emphasizing. And this comes from the top part of the syllabus we considered on the first day. So I'm just reading from the syllabus. If you recall, I said that to succeed in this class, you will have to, 1, be familiar with a range of theoretical material and key logical concepts that set out the underlying rationale for the various exercise questions you will be working on throughout the semester. So that's the stuff that goes on in the videos for the most part, where I'm explaining the rationale for engaging in certain procedures for you. The second part, instill a deeper practical awareness of how to carry out various logical computations successfully by actually completing those exercise questions. The deeper practical learning can only be gained by actually doing exercise questions. I can't explain to you what you can learn from actually doing a fair number of proof construction questions yourself. The only way to learn proofs so that you can understand them in a deeper way is by actually doing proof construction questions. A few people have asked me about the assignments themselves, whether they need to be handed in, and the answer is no, they don't need to be handed in, but they need to be done. The assignments are the best way for you to study the material in order to master it and do well on the exams. So it's up to you as an adult to do that extra part that needs to be done in order to succeed in this course. By and large, I can confidently say, those people who do most or all of the exercise questions tend to do very well in this course. Those people, even if they listen to all the instruction but don't do any of the exercise questions, and thus don't gain that deeper inner understanding that's necessary, tend to not do very well on the exam. So you need to do these exercise questions. You need to learn from a practical standpoint the nuts and bolts of actually carrying things out step by step in order to understand the concepts in this course in the way that you need to understand them. So having said that, if you've gone through the earlier part of this video where we considered this new activity of proof construction, and I went through a number of examples in assignment 5, that is exercise 4.2, it would be in your best interests to pause the video at this point or to turn off the laptop and focus on doing the remainder of the questions in assignment 5. That's the best way to learn in this course. You're not going to learn all this material just by watching the videos from start to finish. From now on, you should think of these videos as consisting of several 10 to 15 minute segments. And there will often be homework, practical activity that's required between the segments. So if you haven't done any of the exercise questions in assignment 5, turn the video off and do those exercise questions. The solutions will be posted very soon, giving you ample time before the exam itself. But I don't want to post them too early, or people give in to temptation and look up the answers instead of going through the valuable learning activity of figuring them out on their own. So, I'm assuming everyone has done the assignment questions the exercise questions in assignment 5. You're now familiar somewhat, both from a theoretical and a practical point of view, how to construct proofs. Now we're going to move on to assignment 6. The difference here is that instead of confining ourselves to 4 rules, all of which are 2-line rules, where you need 2 lines of information in order to employ the rule, we're now going to consider all 8 rules. As far as the 8 rules go, there are 2 one-line rules, addition and simplification. There are 5 two-line rules, conjunction, modus ponens, modus tollens, hypothetical syllogism, and disjunctive syllogism. And then there's the elusive 3-line rule, constructive dilemma. At this point, though, I want to focus on another very basic difference between these 5 rules and these 3 rules. Modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism, and constructive dilemma are all rules that you set up for. All 5 of these rules involve the use of similar information from 2, or in the case of constructive dilemma, 3 different lines. So you are bringing together different parts of your information set in order to infer new information whenever one of these 5 rules are used. On the other hand, addition, conjunction, and simplification are really, for the most part, the rules you set up with. Or another way of putting it, the rules you use to set up rule employment opportunities for these 5 rules. Especially with addition and conjunction, these rules are unique in that you don't need to look for rule employment opportunities. The problem with addition and conjunction is, in fact, that there are too many rule employment opportunities. The overwhelming majority of the legitimate rule employment opportunities with addition or conjunction are useless, however. So unlike these 5 rules, the rules you set up for, with addition and conjunction, you need to be very selective on when you employ it. You need to have a purpose for employing addition or conjunction. And that purpose is eventually demonstrating that if the premises you have been given are true, it's impossible for the assigned conclusion to be false. So consider the following. A In line 4, I did an entirely correct conjunction step involving lines 2 and 3. In line 5, I did an addition step on line 3, and in line 6, I did another addition step on line 5. All 3 of these rule employments are perfectly correct. I've satisfied the requirements for employing the rules, but the problem is these 3 steps don't get me any closer to demonstrating that if the 3 premises are true, then the conclusion must be true as well. And as I said earlier, I could go on endlessly making useless conjunction and addition steps. They're not going to help us. They're not wrong, but they're not going to help you complete the task that you're trying to complete. So with these 2 rules, you need to be very selective. The third setup rule, simplification, is a little bit different in that you have to have a conjunction in order to snap off either of the conjuncts. So there's not going to be limitless opportunities to employ simplification, but largely, I'm afraid I can't say always, but largely, simplifications are going to be done in order to set up for one of the multi-line rule employments. That being said, we're now ready to move on to consider question 6D, where all 8 of the basic rules are up for grabs. That is to say, can potentially be used on any line. So here we have question 6D. I've set up the proof where we have our 3 premises in lines 1, 2, and 3. I've just got capital P for premise in the justification column. Got our assigned conclusion on the top. Now, we look for rule employment opportunities. Can you see any? And remember, there's always going to be addition and conjunction rule employment opportunities. With those, though, we have to ask ourselves, are there any useful addition or conjunction rule employment opportunities? The first thing to notice, we can't use any of the 5 rules you set up for. What this means is we're going to have to do a strategic addition step in order to set up for the employment of one of these 5 rules, namely the modus ponens rule. Consider lines 1 and 3. What we've got is a conditional which tells us if either A or B is true, or both, then C is false. Line 3 tells us A is true. Lines 1 and 3 don't satisfy the modus ponens requirements. We have to have the exact antecedent of that conditional to do modus ponens. We don't have that in line 3. We can get that in line 3, though, by doing this particular addition. So of all the potential addition steps we could have done, this is the one that's actually going to be useful. Now that we've done the addition setup step on line 3, lines 1 and 4 do satisfy the requirements for modus ponens. We've got the conditional on line 1 and the exact antecedent on line 4. So, 1 for modus ponens entitles us to validly derive the consequent of the conditional in line 1, namely tilde C. So you can think of this as sort of a 2-line stage. We have the setup and then the rule employment. Once we've done that, then one of the rules you set up for is available to us, namely 2, 5 disjunctive syllogism gives us the other disjunct, and we're done. So that's a fairly straightforward proof where we made strategic use of the addition rule. We can now move on to question 6H. Here are our three premises. Here is the assigned conclusion. A quick scan and we realize there are no rule employment opportunities using one of the 5 rules that you set up for. But this shouldn't stop us, and the first thing we can do is follows. This is one of the proof construction hints that most logic textbooks have. Anytime you have a conjunction in your premise set, do 2 simplifications in a row in order to bust up that conjunction, in order to have the 2 conjuncts on their own and available for use. So we will follow this very common proof construction strategy hint. 3 simplification, 3 simplification. So we used 3 simplification to get the left conjunct, then we used 3 simplification again, this time to snap off the right conjunct. No need to indicate that in the justification column. 3 simplification of the left, 3 simplification of the right. 3 simplification in both cases is sufficient. Now we've got these 2 sentences along with our 2 premises. We've got 5 lines of information available to us, but we've largely used up the information available in line 3 in the 2 simplifications we've done. Hopefully you remember from the previous proof what we can do now. If you focus on lines 1 and 4, we've got a 2-step routine available for us. Namely, we do the addition step on line 4 in order to set up for (1)6 modus ponens, which gives us the consequent of the conditional in line 1. Hopefully, you notice now we've got an opportunity to do another 2-line routine where we do an addition step in order to set up for a modus ponens. So this is 7 addition, and the addition we want to make, of course, is C or D, because that's the one that's going to be useful for us when we move to 2-8 modus ponens. To derive the consequent of the conditional in line 2, which is the disjunction E or F. Now, we've got 9 lines of information to scan. We're looking for F. Hopefully you're familiar enough with the rules that you don't find it too difficult to spot that the relevant subset of our 9 lines of available information here is 5, 9, disjunctive syllogism, and that gives us F. the assigned conclusion. So this time, we started off with 3 premises. It took us 7 lines of inference, each of which is a valid rule of inference and was applied to a subset of the available information in order to demonstrate that if these 3 sentences are true, F must be true as well. So we're done. We can now move on to question 6I. Normally I don't do 2 questions in a row. I'd like to just do a sample of the exercise questions in class and leave the majority of them for you. But 6I has a particular situation that I think is worth emphasizing here. Hopefully there are some familiar aspects of question 6I from what we've done earlier. So, there are no rule employment opportunities for the rules you set up for. There is, though, once again, an opportunity to bust up the conjunction. And as the very common proof strategy hint tells us, we can do 2 simplifications in a row in order to snap off the 2 conjuncts in a conjunction. Now, déjà vu all over again. We're going to do the addition step setup for a modus ponens. And the addition we want to do is F or G, so that's for addition. Now 1,6 modus ponens will give us tilde A. We can end things off 2,7 disjunctive syllogism to give us the right disjunctive line 2, which is the required conclusion. So this took us 5 lines or 5 inference steps in order to demonstrate that if the 3 premises are true, it's impossible for the conclusion to be false. One thing to notice here, though, is that step 5 was useless in the sense that snapping off the left conjunct was very useful for us, because having snapped off the left conjunct of line 3, we can then do an addition in order to do the modus ponens. But snapping off the right conjunct of line 3 did nothing for us as far as advancing our project of demonstrating that if all 3 of the premises are true, it's impossible for the conclusion to be false. Here's what I'd like to emphasize, though. It isn't wrong for that reason. So what we have here, and I'll just leave it up, is a proof that contains one more inference step, namely line 5, than is absolutely necessary. But nonetheless, this is a completely correct proof which would receive full marks. Here's the standard by which I mark the proofs. This is the standard by which logic teachers in general mark the proofs. Every inference step, that is every line in the proof after the premises, has to be a correct application of one of the available rules to some subset of the available information. So in line 4, we employ the simplification rule to line 3, more specifically the left-hand side of line 3. That's a correct employment of that rule. It's also correct when we do this one. The fact that it's useless doesn't make it wrong. What we can say is that this proof is less elegant than the 7-line version, which went straight from lines 4 to 6 and didn't do line 5, but you don't get marks deducted for useless inferences. So you don't have to worry about that, although when you become more familiar with the process of proof construction, you'll find it just dawning on you if you were to see a proof like this. Okay, I can snap off F, the left conjunct of line 3, and then do an addition step on it to set up for the modus ponens, but I needn't bother snapping off the right conjunct. So the common basic strategy hint, snap off the two conjuncts of any conjunction you have in your premise set. You can move beyond it once you become more experienced at constructing proofs, but it'll never steer you wrong. This isn't an error in the proof. You just have to make sure that every line in the proof is a correct employment of one of the rules to some subset of your available information, which of course is increasing line by line as you proceed through the proof. Here's another question. It's not on the assignment 6. Let's see how we can do with this one though. As we notice, are there any rule employment opportunities for any of the rules you set up for? It doesn't seem so. We do have a triple conjunction, that is a conjunction of a smaller conjunction and a negated sentence. So in looking over the proof, you might notice, well, M and R don't occur anywhere else in the proof but there. So let's do a simplification on the right conjunct, tilde T, but we won't bother with the left one. It's not wrong, but it's just an unnecessary step. Now we can do 2-5 modus tollens to get tilde K, the negation of the antecedent of line 2. Now we can do 4-6 disjunctive syllogism to get the conjunction C and D, which is the right disjunct of the disjunction in 4, and also the antecedent of line 1. So we definitely don't want to be busting up that conjunction. There's a straightforward use for it, just as it is. So now 1-7 modus ponens will give us the conditional, which is the consequent of the larger conditional in line 1, namely H horseshoe T. Now, we can use tilde T again for a modus tollens. 5-8 modus tollens will give us tilde h. So that's a 5-step proof. We didn't bother doing the second simplification step. We could have done that and made it a 6-line proof. So this would receive full marks. Some of you, I'm hoping, might have noticed another way to do the proof, however. And that is when we're scanning the initial data set, it turns out that there is an opportunity to employ one of the rules you set up for, namely the elusive constructive dilemma. What does the constructive dilemma require again? You have to have a disjunction, and that disjunction is related to two conditionals in the following way. The two disjuncts are the two antecedents of those two conditionals. So we have this. So we can go 1, 2, 4, constructive dilemma, and what will that give us? That will give us a disjunction of the two consequents of the conditionals. So that's going to be H horseshoe T or T. Now, once again, we can do the simplification step on line 3 that we did in the other proof. We are, after all, working with the same information. We can now do a disjunctive syllogism on lines 5 and 6 to get the left disjunctive 5, which is the conditional H horseshoe T, and we can end off the proof 6, 7 modus tollens to get tilde H. So we figured out how to do it one line shorter. So this is a more insightful way to do the proof. Either of the two proofs, though, would receive full marks, as would the one that's 10 lines and does both simplifications on 3. So remember, what you're required to demonstrate is a series of inference steps, each one of which is the correct application of one of the rules to some subset of the available data. And keep in mind that as the proof proceeds, the set of available data is increasing line by line.